Hello, today we are looking at 13.5, the law of sines, and we use the law of sines to solve a triangle with no right angle. You can use the law of cosines or the law of sines. We talked about the law of cosines yesterday. So in order to use the law of sines, there's certain criteria that you're going to need, just like there was criteria needed for cosines. For a law of sines, you need two angles in any side, so angle, side, or the included side, so angle, side, angle. Or you need two sides and an angle opposite of them, which is SSA, because remember, we don't say any bad words in math class. Learned about, I think last year, depending on who your teacher was, you learned that this was the booty theorem. And the booty theorem is bad. We don't say the booty word. Okay, so let's look at the law of sines and what the law of sines actually is. We talked about when we name a triangle, I can name my ABC wherever I want. But if I name side A has to be opposite of angle A. Side B has to be opposite angle B, and side C has to be opposite of angle C. And our law of sines, the actual law of sines, I think is easier than the law of cosines, but there's going to be a trick coming up in just a little bit that's going to make it harder. So the law of sines is the sine of angle A over side A is equal to the sine of angle B over side B, and the sine of angle C over side C. This is the way that we're always going to look at it, but no, that's the same thing because this is just a proportion, and you learned about proportions last year, as if you would put the sides on top and the angles on the bottom. And when you learned about proportions last year, you learned that the most important part is that you're just consistent. So we're always going to do it the first way with the angles on top and the sides on the bottom. But if you want to do the sides on top, that's fine. Just make sure that you always put sides on top and the angles are always on the bottom. So let's look at our first one. We have angle, side. The problem is you're going to get to triangles, and I'm not going to say use law of cosine, use the law of sine. You have to look at the setup of what you're given and determine, because this is angle, side, I have to use the law of sines. So as we talked about before, when you solve for a triangle, there are 6 pieces of information, 3 sides and 3 angles. I always write down what I'm given. So I see that I'm given angle B is 28 degrees, angle C is 103 degrees, and we're given side B is 26. That's why it is so important that you remember that side B is opposite of angle B, because if you fill that 26 in anywhere else, it's going to cause an issue for us. So we are trying to solve for side A, side C, and angle A. Those are the 3 pieces of information that we are missing. When you are using the law of sines, the way that you know where to start is you look to see which proportion is completely given to you. I could write out my proportion every time, so sine of angle A over A, and see what I'm given. If this makes it easier for you, I wouldn't recommend this because I think it's almost a waste of time, not completely a waste of time, but I don't know the sine of angle A. I don't know side A. I know angle B. I know side B. I know angle C. I don't know side C. Oops, forgot to fill that angle in. Now, you could have seen it from our setup, or you definitely should see it here, is we have both side B and we have angle B. That means that that's the full proportion that I'm going to use every single time. So I'm going to go ahead and copy that down. Now I'm going to choose, am I going to use the first ratio or the last ratio? When I look at the first ratio, I don't know side A or angle A. I can't have 2 unknowns in an equation because I can't solve. So that means that the first thing that I have to solve for, no matter what here, is side C because of the given information. This is the only proportion that I can set up that only gives me 1 unknown. And if you forgot how to solve a proportion, all you do is cross multiply. So we've got C times the sine of 28 is equal to 26 times the sine of 103. What we are trying to solve for here is c. C is being multiplied by sine of 28, so to get c by itself, we can just divide both sides by sine of 28. So we get c is equal to 26 sine of 103 divided by the sine of angle 28 degrees. Again, notice that these are in degrees, so when we go to our calculator, we want to make sure that we are in degree mode. So if you don't have your calculator out, go ahead and press pause and get it out. If not, let's go ahead and plug this into our calculator. Okay, remember the first thing I'm going to check is to make sure that that calculator is in degree mode. I see that degrees are highlighted, so I'm good. 26 sine of 103. I want to make sure I don't forget to close out that parentheses because I want the sine of only that 103 divided by the sine of 28. That one's not as important to close just because nothing's coming after it. We hit enter and we get that c is going to be about 53 point. Normally I round to the nearest tenth, but if I round to the nearest tenth, then I'm rounding to the nearest whole number, so I'm just going to say 0.96. Now, given the information that we started with, solving for angle C was the only proportion that I could start by setting up. That, however, is not the only piece of information I could have found. The other piece of information that I could have found from the very beginning was angle A. We know that all three angles have to add up to 180, so if I want to find the measure of angle A, we take 180 minus 28 minus 103, and we find that the measure of angle A is 49 degrees. We fill that into our 6 pieces of information. As soon as I have that sine of 49 degrees, now I'm only missing one piece in this ratio. When I go back to solve for side A, even though I now know this whole ratio for C, the side and the angle, I'm always going to use the information given to me. I had to round to get 53.96. So if I use this, A is going to be even farther off than if I use the given value. So always use the given values whenever possible. So our proportion to find side A, we have our sine of B, which is 28, over side B, our sine of our angle A over our unknown side A. Again, we cross multiply, so A times sine of 28 is equal to 26 times the sine of 40, ran out of room. Let's make that a little bit smaller. Again, our unknown is not inside of that sine, it's A times sine, so I can divide by sine, and we get A is equal to 26 sine of 49 all over sine of 28. Then we go to our calculator, and again, I stress this enough, make sure that you are having your calculator in front of you, typing these numbers in with me. Watching me do it is not going to help you. So we get that our A value is going to be about 41.8. And now we have all 6 pieces of information that we need. One thing that you want to be careful about is don't assume the size of sides or the size of angles based on the picture. Most of the time you're not even given a picture, you're just given written information and you draw the picture. So don't base anything off of the picture. This is the one time that the picture is not even going to be close to what's really going on. Okay, so that was angle, angle, side. We go ahead and turn on over to the back page. We have the dreaded booty theorem. When we have SSA, our bad word, we have exceptions. So I think that setting up the proportions for sine are easier. It's less work than the law of cosines. But the law of cosines is easier in the fact that you don't have any hidden things. With our Booty theorem, you're not always going to have a triangle. Sometimes you'll have one triangle, so there's one solution. Sometimes you have two triangles, and sometimes you have no triangles. When this happens, the time we have this exception is if the opposite side is less than the adjacent side, you're going to have two or no solutions. If the opposite side is greater than the adjacent side, you only have one solution. And you don't really have to know the side comparisons and whatnot. You just have to make sure that you check. As soon as you see that you have a Booty theorem, I always put a star next to it. I put a big star next to it before I even get started so I don't forget to check for that second triangle. And where we get two triangles from? Well, obviously we know we can get no triangle. If we have a theta, so we have an angle, and we're saying that that opposite side is less than the adjacent side. So this side opposite is shorter than the adjacent. If that opposite side is shorter and it's not long enough, it's not going to reach the other side, therefore no triangle was formed. That one's pretty easy to see. Or our other scenario is, let's get a picture. This side and this side are congruent. So if that's opposite, or that the opposite side is less than the adjacent side, but it comes in, this could be one triangle. That same side, instead of coming in, can go out. When it goes out, it creates this whole second triangle. So that's why there are two triangle options. I'm not going to quiz you or test you on when are there two solutions, when are there no, when are there one. You just have to know to check. So don't worry about having to know when you use each one. Just know if it's a Booty theorem, you have to always check. And to check it, you ask yourself two questions. You're going to solve for an angle first, and when you solve for that angle, you ask yourself, does the angle fit? And we know that when we add up our angles A and B and C, all three angles have to be less than 180. So when you check that first angle, those two angles have to add up to be less than 180. If 3 have to add up to be less than 180, then definitely 2 have to add up to be less than 180. If the angle fits, then you check, does the supplement fit? And we know that the supplement of an angle is 180 minus the original angle. So we know that two angles are supplements if they add up to 180. If the angle fits and the supplement fits, then we have two triangles. So when we look at this one, we have our angle ABC. We see that we have side, angle. As soon as we recognize that we have side, angle, we have a big star. We know that as I start this problem, I have three different scenarios. I could have no triangles, I could have one triangle, or I could have two triangles. The hard part is if you forget to check for that second triangle, there's a lot of work that goes into one triangle. So on a quiz or test perhaps, when you have two triangles and you don't even start looking for that second triangle, it could cost you a lot of points. So let's go ahead and start. We fill in the given information. Angle A is 70. Angle B, don't know. Angle C, don't know. Side C is 160. And side A is 155. So what we're looking to find are those three pieces. We see that we are given side A and angle A. If I'm given side A and angle A, that is the ratio that I'm going to use in my proportion in each one. So I know I'm going to have sine of 70 over 155. I can't solve for anything in B right now because both side B and angle B are unknown, so I have to solve for angle C. So sine of angle C over 160, we cross multiply. 160 times sine of 70 is equal to 155 sine of angle C. I want to get my variable by itself, so I divide by 155. So sine of angle C is 160 times sine of 70, all divided by 155. Notice this time we are solving for an angle. When I'm solving for an angle, we have to use inverse sine. And I'm going to plug all of that into my calculator. So second sine, 160. And we're taking the second sine of that whole thing. Oops, not divided by. Sine of 70. Make sure that you close out that 70, and then divide 155. And then the second parentheses closes out the whole thing. So we see that our angle C is going to be 75.93. We've got to make sure that we remember to change to degree, minutes, and seconds. And we find that angle C is equal to 75 degrees and 55 minutes, but we've got 52 seconds, which means it's going to round up to 56 minutes. Remember, anything over 30 is going to make it round up. So before we know this is going to be our answer, we say, does it fit? So we already have one angle given to us, and that one angle is 70. And we just found that this is 75 degrees, 56 minutes. I ask myself, is that less than 180? Well, let's just round it to 76. 70 and 76 is 146. So yes, it fits. So I can go ahead and fill that in under angle C. So 75 degrees and 56 minutes. But we're not done yet. We have to see, does the supplement fit? So we know that the supplement of 75 degrees and 56 minutes, we just subtract that from 180. So the supplement is 104 degrees and 4 minutes. We already have the 70 degree given to us from the really original. That's going to be 174 degrees and 4 minutes. We just have to have it be less than 180. And yes, that is 180. This means we have a second triangle. You have to show me these checks. On a quiz or test, I will be looking for that. If I don't see that, you will lose points. So make sure that you are checking, does the angle fit and does the supplement fit? Now, what does that mean? That means we have two triangles. So we go ahead and I have to fill this out 2 times. All of the given information is going to be true for both. So we have our 6 pieces of information again. We were given A was 155. We were given C was 160. We were given that angle A is 70. So we're still finding the same 3 pieces in that second triangle. In our first triangle, 75 degrees and 56 minutes was the first angle that we found, 75/56. It fit, so that went there. Then we checked the supplement. The supplement also fit, so the supplement becomes our angle C over here. Again, the 3 given pieces of information are going to be true for the first triangle and the second triangle. We are solving for the same 3 pieces of information in both triangles. The first angle fit gets filled into the first one. The supplement, if it fits, gets filled in for your missing angle in the next one. I would not work with both triangles at once. I would complete one triangle. Once you're done with one triangle, move on to the second triangle. So let's go ahead and finish up triangle 1. We have 2 of our angles, we have 2 of our sides. We don't have either of these pieces of information, but we can find angle B. because we know that all three angles add up to 180. We subtract those three pieces, 180 minus 70 minus 75 degrees, 56 minutes, and we find that angle B is 34 degrees and 4 minutes. And now we're to our last piece of information, which is side B. Again, we start with the full ratio that we were given. We don't want to use the rounded ones. We want to use the givens. Sine of 34 degrees, 4 minutes, all over side B. We cross multiply. And then we divide. So B is going to be equal to 155 sine of 34 degrees 4 minutes divided by sine of 70. Don't forget to close out those parentheses. As we enter that in, we find that it is going to be 92.4. That is the first 6 pieces of information needed for triangle 1. What I want you to do now is press pause and see if you can complete the 2 missing pieces for triangle 2. Alright, let's see how you did. I forgot to fill that in. The first thing that you should have done is solve for angle B by subtracting the 2 angles that you have away from 180. And we get 5 degrees, 56 minutes. Then we make sure that we use our ratio of sine A over side B, or side A, because those were the 2 pieces that were given to us. We don't want to use the rounded pieces from C. We set that equal to the angle over our side. We cross multiply, we divide, and don't forget that the degrees and minute markers are found in the same place as your degrees minute second conversion. So hopefully you did well on that one. Just remember this, the setup and the solving for sine, I personally think is easier than cosine. The trouble is, anytime that you have the Booty theorem, you've got to make sure that you check. There are different scenarios that are going to play out. Okay, another long video, I know, but we're not going to have some videos for a while, so that's good news. Okay, but we are all done for today.